It's not even matter yet, just a point of raging energy. It was the beginning of the universe and everything in it.
Everything was simple. All the forces that we know about today were one and the same. The universe was amorphous. It had no structure.
In that instant of creation, all the laws of physics, the very forces that engineer our universe, began to take shape. The first force to emerge was gravity. The fate of the universe, its size, structure, and everything in it, was decided in that moment. Carlos Frenk studies how gravity shaped the universe by creating artificial universes in this supercomputer. He gives each one a different amount of gravity. The first one he tried had too little, resulting in nothing.
Gravity, it has shaped our universe. Or if gravity was weaker than it is, we would have a very boring universe in which everything would be flying apart so fast that there would be no galaxies forming.
Next, he programmed a universe with too much gravity.
If gravity was stronger than we think it is, again, we'll end up with a failed universe. Everything will end up in black holes. It has to be just so. It has to be just right.
Luckily for us, the Big Bang got it just right. The perfect amount of gravity. In the turmoil of forces after gravity emerged, still a fraction of a second after the Big Bang, a shock wave of energy erupted and expanded the universe in all directions at incredible speed.
All of space expanded by an unbelievably large factor in a fraction of a second. We think that in less than a millionth of a millionth of a millionth of a millionth of a second, space expanded by a factor bigger than a million, 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 million times.
And that's faster than the speed of light. But doesn't that break one of the laws of physics?
Even school children know that, quote, you can't go faster than the speed of light. But actually, there's a loophole there. You see, nothing can go faster than light. Nothing being empty space.
This idea gives even the best minds in science a headache. But it's critical to understanding the early universe. Scientists think it took less than a millionth of a millionth of a millionth of a millionth of a second for the universe to expand from the size of an atom to a tennis ball. That may not sound like much, but it's like a golf ball expanding to the size of the Earth in the same amount of time. That means it was expanding faster than the speed of light.
So many things were happening so fast in the early universe because everything was so close together that we need a new unit of time to describe things.
It's called Planck time. To understand just how short a Planck time is, consider this. There are more units of Planck time in 1 second than all the seconds since the Big Bang. The calculation is mind-boggling.